Hello, in this video, we will continue our look in graph theory by introducing circuits. We have already talked about something called a path. A path, as you may remember, is, a way to get from here to there, route, basically, right? A circuit is also a path. Notice our definition at the bottom. A circuit is a path, but there's more, that begins and ends at the same vertex. So you basically start at one spot, take some kind of route, and come back to where you started. Kind of think of it as leaving your house, right? Here's your home, and you're traveling over here, you're traveling over here, you're traveling over here, travel over here, you may go back over here, finally you go back home. All right. Now, but the other thing to be clear of is it's a path, right? So remember that paths can revisit vertices, a vertice, but it may not revisit an edge. All right, so it has to be a unique edge. So let's take a look at an example. Here is a graph. This is the graph of the Konigsberg Bridge problem. And let's take a look at, remind ourselves what a path would look like, and let's compare that to circuit. Now, I know that circuits are paths, so I'm not trying to say that if I put it in the right-hand column, it is not a path. But let's just put only a path on the left. All right, let's take a look at some of the possibilities. Well, we could start at A and go to D in a quite easy way. We could go A to R and then from R to D. That would be a path from A to D. It would look like this: A, R, D. Now we can easily make that into a circuit just by going back to A at the very end. We put this line back to A, and notice how we have this, when we have a circuit, it kind of looks like an enclosed shape. We have a complete closed circuit, so to speak. So that one would be listed as A to R to D, and then back to A. Note that you will always start and end with the same letter on a circuit. Now, there are many options here, and I'm just going to show you a few more, and then I'm going to have you try a few as well. We could have a little bit of a longer circuit. We could go from A to R, and then from R back to A, and then maybe over to D, and then back over to L, and back up to A. Now, remember, the key is where you start. In this case, I was starting at A. You must also end at the same spot. Now, if we can recall what we did right there, right? That was a circuit that started at A. It went to R. It went back to A. And then it went over to D. And then it went L. And then back to A. Again, starting at the same spot. Now, you can easily make that a path just by erasing the very last piece. Or you could erase several pieces. But as long as you don't start it in at the same spot, it is only a path and not a circuit. So that when I erase that very last edge, that could be a path only, A, R, A, D, L. And there would be no A at the end. All right, so you can have circuits that are longer and some that are shorter. You can have multiple circuits within the same picture. There's lots of different kinds of circuits. And later on in this unit, we'll study a specific or special type of circuit. I'm going to show you a map here. This is a pretty complex bridge problem. Notice there's lots of land masses all labeled as letters A, B, C, D, E, and F, and then lots of bridges, especially from island D, right? If you look at this island here in the middle, island T has so many bridges connected to it. And so there are paths. Like let's take a look at, and there are circuits. Let's look at a path only, for example. Well, if I wanted to start, let's say I started on island D because there's so many bridges, I'm going to draw my little stick figure right in there. Okay. And then I can say, well, I could go off this, across that bridge into F, and then cross over that bridge back over to E, and then go down to C and end up over here at B. That would be a path, right? I would be starting on island D and then going to landmass F, and then over to island E, down to landmass C, and finally over to B. That would be a path only. But if I wanted a circuit, I would need to start and stop at the same spot. I could finish this out perhaps by going back to where I started. And of course, there's lots of ways to do it. I could continue traveling to all the landmasses. I could go over to A, and then I could go back to D, right? Kind of back to where I started. And so that would become a complete circuit. It would be D, F, E, C, B, and then I went up to A and then went back to D. There is a lot of circuit opportunities. So I'm going to give you couple questions right now related to if something is a circuit or not on this picture and some others. Okay, now that you've looked at those examples, and hopefully you've gotten them all correct, I hope that you've learned a lot more about what makes a circuit a circuit.